Hey, what's going on, guys? Let's find out whether this series converges or diverges using ratio test for series. The first thing we have to do is we have to take the limit n approaches infinity absolute value of an plus 1 over an and check whether it is less than 1 or greater than 1 or equal to 1. If it's less than 1, it converges. If it's equal to 1, no conclusion, and if it's greater than 1, it diverges. So let's see what we get from this one. Let's take the limit first. So limit n approaches infinity, and an plus 1 is basically mean that wherever we have n, we just add 1 to that. So here we have 4 power n. So this is going to be 4 power n plus 1. And then we have n factorial. That's going to become n plus 1 factorial power 2, right? And then in the denominator we have n plus 2, and if we add 1 to that, that's going to become n plus 3. And n plus 3, and also we have factorial. So this is going to be n plus 3 factorial. And this is what we have for an plus 1. Now we have to divide this one by the original function, this function right here. But dividing this one by this function is same as multiplying this one by its reciprocal. So this is same as dividing this one by this is same as multiplying this one by n plus 2 factorial over 4n n factorial square, because when you divide it will flip around and come top, right? So that's how we derive this one. And let's see what we can cancel from this. And here we can expand this one a little bit more to make everything clear, right? We can arrange in similar patterns, like if you have 4 power n, we can bring this denominator 4 power n close to that so we can see everything clearly. So let's do that part. Limit n approaches infinity. So first we have 4 power n plus 1, and I'm going to bring this 4 power n and write it here. So this is going to become 4 power n plus over 4 power n, and then we have n plus 1 factorial square. So this is same as multiplying this one by twice. So we can write this one as n plus 1 factorial and then n plus 1 factorial again, right? And in the denominator, if you see, we have again n factorial square. So we can write this one as n factorial times n factorial, right? Same thing. And then we have n plus 2 factorial remaining in the numerator. So multiply by n plus 2 factorial in the numerator, and in the denominator we have n plus 3 factorials. N plus 3 factorial, right? Now we have expanded everything. So this one is same as this one. We just expanded everything, and let's see what we can cancel from this. So whenever you have 4 power n plus 1, this is same as multiplying this one. 4 power n times 4 power 1. If you multiply, you will get the same answer. So in this case, what we can do, we can cancel this 4 power n, 4 power n. And let's do that first. So if we cancel this one, 4 power 1 is remaining. And then we have n plus 1 factorial over n factorial. So if you, this is easy cancelling, like n factorial cancel with this one. If you can't see that directly, you can write some terms out. For example, this n plus 1, let's say this is the larger than 2 or 3, right? So if you see n plus 1 factorial goes like n plus 1, then n, because 1, every time it reduces one value. So this is going to become n plus 1, n, then n minus 1, and n minus 2, and it goes like until 2, 1, right? And in the denominator we have n factorial. So that one will expand like n factorial, n times n minus 1 and n minus 2, and it will reduce to 2, it will end up with 2, 1, right? So if it's greater than 2 or 1. So here you can see already this whole thing will cancel with this one, right? So that's what we are going to do right here. We can cancel this n factorial with this factorial, and this is the only term that's going to remain when we have situation like this. For this one, same thing. N factorial cancel, this factorial cancel, and this is the only thing remains. And if you think about it, this is also same pattern. like this one n plus 3, that will reduce like every time it decreases one term, n plus 3, n plus 2, n plus 1, right? And in the numerator we have n plus 2. N plus 2 will reduce like n plus 2, n plus 1, n, and it goes until 2, 1, right? So you can see that we can cancel the whole thing with this one. So this is same as cancelling this one with this one. So this is the only thing that's going to remain. So we simplified everything. Now let's write the new term to see what's going to be the limit. So let's see. Let's continue this one right here. Erase this part and write the new term. So here we are going to have the new term. So we are going to have limit n approaches infinity, absolute value. So this is not bracket, this is absolute value. Right. So this is what it is, and then if you look at this one, we have 4 power 1 is remaining on the numerator. So we write that one right here, 4, and then we have n plus 1, n plus 1. We write that one, n plus 1, n plus 1. And then we have n plus 3 in the numerator, n plus 3 in the numerator. So that's all we have. Everything else is cancelled, right? So let's see what we get from this one. If you see this n times n is going to be n square, and the denominator we have less power, n. So the power in the numerator is higher than the denominator, so the answer is going to be infinity. But if you are not sure, you can expand this one. Limit n approaches infinity, and if you expand this one, that's going to be 4 times n square plus 2n plus 1, right? In the denominator we have n plus 3, and if you see, then this power in the numerator is higher, n square, right? In the denominator we have n power 1. So whenever you have the power is higher than the denominator, that means that's infinity. If you take the limit, that's going to be infinity. So this is infinity, and infinity is definitely greater than 1, therefore this diverges. So according to the ratio test, if we get value that's greater than 1, this series diverges. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.